Alright, let's do another math multi-subject CST problem, practice problem. And here we have a vocabulary type of question. And it states, the blank property states that you can change the order of the terms or factors. So the key thing we want to pay attention to is change. What does the property do? It changes the order of the terms or factors. So which property changes the order of the terms or factors? Now let's go through the first one. Commutative property. What is the commutative property? The commutative property basically says if I have, for example, A plus B plus C, I can change the order. Interesting. Keyword here. Change the order of my terms to get the same answer. So instead of A plus B plus C, I could write B plus A plus C. Or I could write, for example, C plus A plus B, right? We know we can compare it to numbers if you don't like letters, right? We know 1 plus 2 is the same thing as 2 plus 1. So what is this commutative property telling me? It's telling me that if we change the order of my terms, we can get the same solution. So that looks like what we're looking for, because we're looking for something that changes, a property that changes the order of our terms. So let's say it's A, but let's just check out the other ones real quick. The associative property is something like this. We have A plus B plus C is equal to A plus B plus C, but we want to associate or focus on two terms at a time. So maybe on the left side, I want to focus on A plus B first. I'll wrap it in parentheses. On the right side, I want to focus on B plus C first. Right? And we know these are equal, right? Because if you think of it, let's go back to our numbers, right? 1 plus 2 plus 3 is the same as 1 plus 2 plus 3, right? 1 plus 2 is 3, 3 plus 3 is 6. 1 plus 2 plus 3 is 1 plus 5, and 1 plus 5 is 6, right? Doesn't matter which ones we add first, we'll still get the same result. But it's just the associative property tells us we can group two terms at a time, two different terms, and we'll get the same result. We are associating them like they're friends. Like we're saying, hey, let's talk about A and B first. No. Instead, let's talk about B and C first, right? So all we're doing is we're grouping it differently, but we're not changing the order of the terms. It's still going to be A, B, C in that order. A, B, C in that order. So the order of the terms is not changing. That's why it's not associative. Identity just takes a number like 5 and it does something to it to keep it 5. So I can do 5 plus 0 is 5, or 5 times 1 is 5. Identity just means it becomes itself. 5 becomes itself. Again, we have no changing of the order of terms here. And distributive, which we did in the last problem, is simply, if I have a number outside of parenthesis, I'm just going to distribute it to both terms. Multiply it to both terms. We're not changing any order of terms here, so distributive's a no-go as well. So commutative is our answer. A lot of students get confused between the commutative property and the associative property. So let's do an example with pictures. Let's talk about a train. So this train has two cars. This train has two cars. And this train is, I don't know, it's going to New York. It's headed to New York. If, let's say, 3 friends are going to New York by this train. One friend is in this cart. One friend is in this cart. And one friend is in this cart. So, this is the exact same thing. Let me copy this picture, actually. This is the exact same thing as if I had... This friend is still here. This guy is still here, and this guy is still here. So we still, if we look from left to right, we still have the red friend, the green friend, and the blue friend. And on the bottom is the red friend, and the green friend, and the blue friend. Except on the top picture, the red and green friend are in the same cart, so they get to talk to each other. So we care about, they're probably closer friends. The bottom cart, the green and the blue guy are in the same cart, so they are the more best friends. So this represents the associative property. All 3 friends will still end up in the same place, New York, but we can focus on the 2 that are in the same cart together first, because they probably have more interesting conversation. This represents the associative property. Associative. Now let's talk about the commutative property. Let's still have a train with 2 cars, and they're both going to, I don't know, so it's Los Angeles. Same destination. And then we have one friend standing here, and another friend standing here. But on this train, we have the green friend standing on the left, and the right friend standing on the blue friend standing on the right. So again, both trains are going to the same location, but inside the same train cart, they're switching places. But they're still talking to each other all the same. There's no difference in their focus. So I like to use a train example because what do you do on a train? On a train, you commute, right? So think about a train when you think about the commutative property. When you're sitting with your friend on the train, you might move around the same cart because maybe you'll get a seat, maybe you'll stand up, maybe you'll walk to the back if it's too crowded. But you're commuting with each other in the same cart. So this represents the commutative property. I hope that visual helped if you had any confusion about the terms. Again, answer number 2 is commutative property. It's the property that changes the order of the terms.